I had chicken. That's how me feeling weird yesterday. I had to take a nap because of them.
Why she have something over her nose?
I know my number.
Josh said. 60. Yes, literally raised his hand. Then grab one. Oh, I can have it in the game. Thank you. Thank you. All right.
Wish night right now.
I'm sorry.
So I do want to point this out. Looking up here, I can see a major reason why a lot of us struggle in this class. Can anyone take a guess what I'm referring to? Why I would say that some of us are struggling?
Who is to your left?
Who is to your left? And what is their favorite food? And what did most of us put?
The favorite food.
I know Brandon likes corn. I appreciate that. I know Claire likes spaghetti. I know Jeremy and his favorite food is pizza. But most of y'all, I have no clue who you even are. So even if I wanted to know, right? Which I mean, I do want to know, but like, I can't know because you're not putting it there. Guys, if you don't follow directions, it is really darn hard to learn. If you do not follow directions, it is really darn hard to learn.
Praise the Lord.
Okay. Am I talking right now?
Yes.
I'll talk. Stop.
Push it up, man.
Stop talking back. When I say stop, it's not a time for you to start getting at me. So, all jokes aside, legitimately, guys, a big part of our struggle the last few days has been that we have not followed directions. If you don't follow the directions for the task, you are going to completely miss what I'm trying to get you to see.
Yes, sir.
Now, let's look at the summary of what we learned yesterday. So, we learned how to create a triangle polydem.
Polydem.
Polygon.
Put that. Put that.
Pythagorean theorem.
I guess that's what they mean.
Is that what they mean?
That's what I would have guessed. Polydem.
Okay. We learned about angles of reference. So even though triangles are different sizes, they have the same ratio. Now we need to be careful. Right here, okay? I need to point this out. And this is an important summary of a key detail that we're going to get back to in a second that you need to know. Do all triangles have the same ratios?
No. Yes. No, it's similar.
Only what kind of triangles are you? Similar triangles. What kind of triangle did we deal with yesterday for the entire time? A right triangle, there was something else. We only yesterday dealt with right triangles with a 60-degree angle. So really, we knew how many angle measures?
One.
Two.
We need two.
Right is
Now, I'm going to come back to what Dee Dee said, because she's not actually wrong. How many angles did you say we knew?
3.
Okay, you said 3.
Oh yeah, because once we know those two, we know the other one.
Hold on, say it one more time, sorry.
Once we know those two, we can figure out the other one.
Once we know 2 of the angles, can't we always figure out the third?
Yeah.
Because if it's a right triangle, what angle do we automatically know?
90.
Right angle, which is how much?
90.
90 degrees. We were told 60 degrees. So then what is the third angle?
30.
30. Remember how every single person had a 30, 60, 90 degree triangle. And I need you to hear me very, very clearly on this. This idea of being different sizes but having the same ratio only works when the angle measures are the same. And that is a fundamental component to what's called trigonometry that we are studying. As Kelsey said, there were a couple of questions on it on the ACT today. And I apologize we didn't quite get there, but we will be there before your next ACT. Alright. Talk about how to calculate ratios, how to find the missing side of a triangle. Ooh, here's some important stuff. How to find the hypotenuse, adjacent, an opposite side of a right triangle using an angle of reference. That person really thought about what we learned yesterday. The more that we, guys, the more that you can write about and talk about the things that we actually learned, the better off you're going to be. And that's important to recognize that we talked about angles of reference, we talked about hypotenuse, we talked about the adjacent side and the opposite side. So let's recap a little bit of that before we move into today's lesson. So here's angles A, B, and C. Here is angle A right here. Let's, yes ma'am.
I know where side A is.
Okay, hold on one second. Hey, y'all, up here. Well, we're going over a lot of the background stuff that you need right here. Okay.
What we get?
Hold on. Okay. Now, first off, I want to point this out. Do we know any of these angle measures right now?
No.
Yes.
Which one do we know, Brandon? Or Gabe? Not Brandon. C? What do you think C is?
We don't know.
Who agrees?
Wait, see.
Zaria agrees. Josh, you agree? Rose? Austin, what were you saying though?
We don't know it, but it looked like it's 90.
Ah, do we actually know that it's 90 right now?
No, we're making a hypotenuse.
Hypothesis?
No, we don't.
Okay. So a hypothesis is a what?
Educated guess.
Kind of. A hypothesis is a prediction. It's what we believe to be true.
Yeah.
The difference between that and an educated guess is an educated guess, we just make the guess and we're done. A hypothesis is something that we could test. Alright? Now, I will point this out. What Austin is saying though is actually very accurate. Does C look like it's a right angle?
Yeah.
Yes. Have we actually measured it to make sure it is?
No.
No. Okay. And so I'm not going to waste the time right now because that's not a priority. I am going to just declare that it's a right angle. Do I know for sure it is? No.
For sure what?
That that's a right angle.
Oh, no?
No, but I am telling you it's a right angle, and we're going to move forward from there. Gentlemen, what is going on with those slides?
He kicked it over here to make it. He kicked it over here to make it.
Why are you
Okay,
Terrence.
Terrence, I want you to get next to Jeremy so that you're not in front of Caleb because this is ridiculous. Stop.
What's that?
Stand trying to play foots on me.
Terrence.
It's open.
Alright. Hey, there are some of us who missed yesterday and need this information, so I need y'all to focus. And there are some of us who are here and still miss this information because we were not mentally here, so I need you to focus and pay attention. So, look, angle A, I'm going to call this my angle of reference. Alright? What side would be opposite from that angle A?
B.
Vertical line. Where B is.
So, hold on, so say again. Across. So remember, opposite means across, and Kelsey, you were describing as this vertical line here?
Adjacent line.
Huh? Wait, I thought we were talking about opposite.
My bad, yeah.
First off, I will point this out. Does anyone know what this vertical line would be named?
Oh.
Which side is it? Hey, do y'all hear how there's like 6 people shouting instead of raising their hands so that we can hear each other respectfully? Shh. Rose. Side A. Multiple people may have said it, but I couldn't hear it. Okay? Jalen, can you tell us why this is called side A?
Me?
Yeah.
I don't know.
So then you need to pay attention to this if you don't know this answer. Claire, can you tell us why this is called side A? Across from what? Angle A. Remember, the sides are named based on the angle that is opposite them. So we would say that this side A is opposite from. Sir? No. So, sorry, dude. Should have taken care of that before class. So, Jalen, what would be adjacent to angle A?
Adjacent? Isn't it that little thing right there?
Which one? The one that's slanted or horizontal?
Top.
This up here is adjacent?
Yeah.
Okay. Austin, what do you think about that? This is the adjacent side up there.
Wait, what? Oh. No.
Why not?
Nah, because that's a hypotenuse.
Remember, what does the word adjacent mean? It means,
Equal.
Next to.
Oh, next.
but how many sides are really next to this angle A?
One.
Two.
Only two are next to it,
Yeah.
but one of those is the hypotenuse, okay? And Gabe, man, I keep flipping Gabe and Brandon. I gotta fix that. It's been a whole semester. Brandon, why is this the hypotenuse?
What is a hypotenuse?
Because, what's it called? Across from the triangle.
There we go. The hypotenuse is opposite from the right angle.
That's also
Hold on, wait a minute. So what is another word called hypotenuse? That's what
Hypothesis is what you were trying to say earlier.
I know, but like hypotenuse, what is a hypotenuse?
We literally just defined it. It's opposite from the right angle.
Hypotenuse, okay, I got it.
Wait, isn't it?
Yeah, I forgot what a hypotenuse.
Well, what would be my adjacent side? Y'all, what side then would be my adjacent?
The bottom.
The bottom, which what would be the name of this side?
A hypotenuse.
Side
More angle.
Dee, why would this be called side B?
Because it's adjacent to the hypotenuse.
No.
It's across from what? Angle B.
Oh, okay.
Remember, angle B is over here, so this adjacent side is side B.
Wait a minute.
What,
Okay,
Dee?
okay, let's okay, so you got an A right there, you got an A right there, you got a B right there, you got a B right there. So what else you got?
At the hypotenuse.
Oh, you did come in different ways, so.
Not just in different ways.
Well, different angles.
No, hold on. The side is always opposite the angle.
So you put them
So
on the
this
opposite
is
side.
angle C,
Uh-huh.
this is side
C.
It's a hypotenuse, but it is side C.
Okay.
If this is angle A, this is,
Angle A opposite of,
but it's
okay.
not an angle, it is a
Side.
side,
Well, side.
okay? So, let me ask this is an important question. Kelsey, actually let's not use that, let's use this. Would that be a side or an angle?
Angle.
Oh,
Okay, raise your hand if you think it's a side.
Yeah, I'm looking at it.
It's lowercase.
Say it again, Zaria.
It's lowercase.
It's lowercase. Remember, the sides are always lowercase. The angles are always
Uppercase.
uppercase. Okay.
Nah, I got it.
Okay. So we got our triangle. This is how it's going to break down. We got to know how to identify our adjacent, our opposite. But I will remind you, what should we identify first to make it easier to know the adjacent and the opposite?
Hypotenuse.
Always identify the hypotenuse first. Okay.
I found out what a hypotenuse is. I didn't even know there was a bad language.
It's hypotenuse.
Hypotenuse.
Alright, I think that covers everything that I see here. Let's get started with today's lesson. No, dude. So, here's what we're working on today. Come on, focus. My class every day yet. Here we are. So, trigonometric ratios.
What is a trigonometry?
That's what we're about to learn about.
Is it on one of these papers?
So, hey, focus. Trigonometric ratios is what this entire unit is on. No, this is algebra 2. No, that's algebra 2. If you get out your green sheet from, did I give it to you yesterday or 2 days ago?
Yesterday.
Do it say reference angle?
It's this sheet. 2 days ago?
But this the right sheet?
Alright, please listen, sir. Seriously? Sir. You gotta stop losing your crap. This is the last one I'm getting. You've been here.
Yep.
Hold on. Can you pass this back? So I do want to point this out. Listen up. Okay? Does anyone see where the trigonometric ratios might show up on the sheet? I didn't use that word, but it is on here.
The right one?
Where it supposed to be?
Right triangle trigonometry.
There we go. Right triangle trigonometry is the same as trigonometric ratios. Okay? What we are learning about are these trigonometric ratios and how they tie into right triangles. So, we're going to wrap up 4.8, our relationships predictable first, and then we're going to jump into trigonometric ratios exploration. We just have one quick note. And so we've already talked about identifying the lengths of a triangle that are opposite from and adjacent to a reference angle, and identifying the hypotenuse. We want to create those ratios. So, we already did that. Sorry, I forgot to take that out. Here's where we ended up yesterday.
What are they?
This is, unfortunately, that 4.8 sheet that I couldn't find for you. And I don't know where my extras are. Like, I had extras yesterday, but they disappeared. Probably. Okay, stop.
What?
Hey, focus up here. She said, did you give them away?
There.
So, here's what I need y'all to pick up out of this. Austin, chill. So what was the ratio that we had here for the opposite sides of the hypotenuse?
0.5135.
0.824.
Which was 5?
No, this is on the back, number 2.
0.865.
There we go, 0.865.
0.5 after that one.
And then 1.75.
And then I think we had exactly the same here. Y'all, too many of us are talking, which means we're
1.73.
not paying attention to learn.
It was 1.7.
Hold on. Remember, if you got close to this ratio but it's a little off, but that's probably just rounding
They're
error,
the
that's
same.
not a different answer. So did you get an answer close to these ratios, Michaela? Yes? So then you're probably good. The bigger thing to notice is that these ratios need to be what? The same. Because that was the whole point, is even though they were different sized triangles, those ratios are the same. That's what we're finishing up right now. So, remember, this is the last time I'm doing this. Y'all packed up a full 90 seconds to 120 seconds before the bell rings, which I know sounds like nothing, but I was almost done with the sentence that you needed most off of this lesson, and none of you would have been able to get it because you already packed up. Okay?
I got the most of it.
So, stop and listen. I am finishing this statement now, but in the future, if you pack up before I finish and tell you to pack up, you're out of luck. So what do you notice about the ratios from the two given triangles? How do these ratios compare to the ratios from the triangle you made on the previous page? And Ari, what did we already say?
The ratios are the same, so
The ratios are the same. So what?
We didn't finish.
And that's the issue. We don't know. And I actually did hear Zaria kind of talking about this earlier, and this is the most important thing to recognize. What do we know about these triangles? Because they are different sizes, but they have the same ratios.
They're similar.
They're similar. The ratios are the same, so the triangles are similar. The concept that drives everything within trigonometry is that similar triangles have the same ratios.
What do I write?
Well, you write it on the 4.8 sheet that I gave you yesterday that you don't have. No, because I don't have anymore. I'm not joking or trying to be funny. I legitimately don't have anymore because y'all take them and then lose them. Obviously not you, but others. So, I need you to hear me very, very, very clearly on this, because this is the detail that most students miss out on, and then they struggle with trig. Which, by the way, trig is just an abbreviation or a shortened version of trigonometry. Okay? The ratios are the same, so the triangles are similar. Because here's the thing that we know, right? We talked about it earlier, and I erased it actually. So first off, what kind of triangle did we have?
A right
A
triangle.
right triangle. Which meant that we have what kind of angle?
Right.
Right angle, which is 90 degrees. But we also were told that we had what other angle? 60 degrees.
And then we also have the 30 degree.
And so let's pause for a second. I want to point this out. We knew it was a right triangle, so we had a 90-degree angle. We had a 60-degree angle as well. And so because of that, we knew the third angle was what? 30 degrees. What do we know about similar triangles? This was the bell ringer from Monday. What do we know about similar triangles? Or similar polygons? I can't do that, sorry. They what? They're alike but different sizes, yes, but what do we know about their angles?
Yeah, they're similar.
The angles aren't similar, the
They're the
angles are,
The same.
okay, what's the more mathematical term?
Congruent.
Congruent, right? Hey, y'all, pay attention.
Yes, sir.
You were good, it was them I was referring to. You might have not been paying attention, which is why you said that as well. But look, every single triangle that we dealt with yesterday had what three angles?
90,
60,
60 and 30. Every single one. So those triangles were what?
Congruent.
The same.
Same.
Similar. Remember, for them to be congruent, the angles have to be congruent and the
Ratio.
side lengths, or the sides have to be congruent.
So then, when the ratios are or whenever they have the same numbers, both sides, then what are they? Congruent or?
So, look, if I have this triangle, 3, 6, this would be 3 root 3, okay? This is just a triangle that I know. I know this because of other details I know about triangles, but 3, 6, 3 root 3, this is a right triangle. That is a triangle. I can have that same exact triangle.
But it had different ratio?
Nope, this isn't ratios. These have the same exact side lengths, right? So these would be congruent. Remember, to be congruent, the sides and the angles all have to be the same. But let's say I have this triangle. Is that congruent? No. But they are similar triangles because one, they got the same angle measures and it's got the same ratios. Well, right angle is a part of it, but it's more, and here's the thing. If they have the same angle measures, then they are going to have the same ratios. That's a principle that we had to skip over, and we're going to talk about it more in a second. It's actually one of the words on your graphic organizer called the angle similarity theorem. And we'll talk about that in a second.
Can you repeat?
So,
We're going to talk about it in a second. Just hold on.
the
You
orange
don't need it yet.
The orange one and the green one are going to be similar, so then that means the green one and the green one will be congruent.
Well, why are the green one and green one congruent?
Because they have the same.
They're the same size?
Yeah, or same size and
Same size,
Like size.
Well, technically not the same size, because this one right here is smaller and that one right there a little bit.
Hold on.
That's
We need
why
to go
it's
back to an
similar.
important detail a lot of us are forgetting. Y'all are going back to the original understanding you had for congruence. Let's look at these triangles again. What can I do to this triangle so that I know that this thing is congruent to this one? Say it one more time. I can translate it. Because if I can use a transformation, a rigid transformation, right, an isometry, if I translate this over and it matches perfectly on top, they are what? They are congruent. For them to match on top perfectly, the sides have to be the same and the angles have to be the same. So they are congruent because I can match one on top of the other. What would I have to do to this green one to get the orange one though?
Have same ratios.
I have to dilate it, I have to stretch it, remember? And if I dilate it, if I stretch it, I would get this figure here. It would have the same angle measures, but different side lengths, but it would have that common ratio. Okay? You don't look like you like that, Matthew.
I just understand like doesn't the ratio also have to be like the same for those two for the triangles?
The ratios here are the same. Okay, are you talking about these two then?
Yeah, those two, are they not going to be congruent figures?
So, no, these are congruent.
Okay.
These are similar.
So I think, So, I'm trying to figure out the ratio, so does the ratios have to be the same for those two also to be congruent?
Yes, okay, I see what you're saying now. Okay, so what Matthew's actually asking is a good point. What I will say is, because these are congruent, yes, the ratios would be the same as well.
Okay.
But congruent, so if figures are similar, the ratios are the same. If they're congruent, the ratios are the same, but more importantly, the sides are exactly the same as well. So you can have them have the same ratio, but them not be congruent. Does that make sense?
Mm-hmm.
Okay. Alright, so moving from there though, this is what we want to recognize then. The ratios are the same, so the triangles are similar, and everything with trig is built off of similar triangles. The other detail to notice is this. What can you infer? That means what can you believe to be true about the angle measures of triangle ABC and triangle DEF?
Oh wait, you put up there measure angle A equals 60 degrees.
So the measure of angle A was 60 degrees,
Based on the other side.
and the measure of angle D was...
60.
Why do we know that those angles have to be 60?
Based on the other side.
What do you mean?
That's what you put.
Because when we did
Based on the other side of the sheet of paper. But what did we see on the other side of the sheet of paper?
that the opposite sides, the hypotenuse and adjacent, when you divide them by.
Similar ratio.
Did we see those same ratios?
Yeah, the same ratio.
Okay. So remember, if we are seeing these same ratios show up, then we have to be dealing with the same angle. And that's what I meant by the other side. So we infer the measure of angle A is 60 degrees, measure of angle D is 60 degrees, because the ratios match from the front side of paper. Okay? So if you need to add an extra detail in there so you can actually use this to study from, then add that. But that's what we want to recognize is, because those ratios are the same, we know that we are dealing with not congruent triangles, but similar triangles. And what do we know about similar triangles? Their angles are the same. Okay? So we're getting the same ratios, so they have to be similar, which also means that their angles have to be congruent. Okay, so make those notes if you need to. Hold on a second. Kayla, she's trying to pay attention to what? Wasn't that you said, hey Kelsey? Alright. Anybody need me to hold on, or are we ready to go? I'm already still writing, so I'll wait. Terry and Sue. Do you have a question? Flip your phone. Number 13.
Huh?
Yeah, I'm in the. Alright. So, here is the second task that someone passed out at the beginning of class. Was it Matthew?
What?
This is the sheet that you have. Okay? So Matthew passed out a sheet at the beginning of class. And here are the objectives for this lesson. We want to be able to determine the trigonometric ratio of an angle. This is a slightly new term, but we'll explicitly define what these are today, or maybe tomorrow. We want to explain why the trigonometric ratios work, and we want to use a trigonometric ratio to determine unknown lengths of right triangles. So, I want you to work within your small group. I'm going to give you 2 minutes. That's it. Are the triangles congruent, similar, or neither? Develop a convincing argument as to the relationship among the triangles. You don't have to write this down, but you need to clearly be discussing it, and I will be randomly calling on 2 or 3 groups for them to share their ideas. So, talk with your small group, figure out whether you think that these are... Actually, let's do this. Hold on. 60 seconds. Stop. Stop and listen. 60 seconds for you to think on your own. Why are you talking while I'm talking? 60 seconds, I want you to think on your own so that you have some ideas before the whole group starts talking. And I'm going to give you 2 minutes to talk with your small group to come up with a reason why we think that these are congruent, similar, or neither. We all good on that? Alright, let's get to work. 60 seconds thinking on your own. 60 seconds thinking on your own. Why are you talking if you're taking 60 seconds to think on your own? No, this is why you listen when I talk. I just want to point out, you're looking at the angles, not the sides. Two minutes, talk with your group.
What you figure out, Jay? That's similar.
I say
How you gonna say that? Like this is-
I mean, if he agrees with you, he agrees with you. Now you need to come up with a reason why.
Who ain't got no. Look at
Okay,
your.
but why?
Stop talking. All they similar.
So you think just these two are similar and just those two are similar?
No, I think they're all.
I think they're rotating down.
I think all of them.
But you only pointed out that some of them have the same angle. If they're all same, huh? Have you checked that yet?
Do I have time?
I know the minute or something, but there's an easy way to tell it. You're focusing on the important idea first.
Now, look
Think about those angles. What we talked about. Okay. But here's the thing, just because they look identical, I kind of guarantee that they were. Could they just be completely different? So I think the idea that they're dilated is a safe way to say, hey, they're not congruent. It doesn't guarantee that they're similar. Let's talk about it a little bit. Why are they similar? What are we thinking?
they similar.
That's not telling me why you think that.
They don't have the same. They don't have the same.
Quiet, but this is good. All right, you got to say that. And then if it's not, go ahead.
Silent.
So one angle is enough to say that they're similar?
Oh, no, well, there might
Be
be.
dilation. And this one just half the size of this one.
Like they
This like fraction.
This way you got it, this one right there, they got one right there.
And then it's that other thing, they
I mean,
similar,
you
but
got,
not the same.
okay.
I would say
Thank you. So raise your hand if as a group you said, hey, these are congruent triangles.